Now we're going to introduce some data structures built into pandas that will help us in manipulating and organizing data. And the main data structure we will use frequently in this class is called the data frame. We're going to just introduce how to create data frames, and we'll also look at how we can manipulate the indices of data frames. So, as we've mentioned before, we can really think of the relationship between these data structures in the sense that I think of a data frame as a collection of series. Those are my different columns here that all share the same index. This is the same election data that we've been looking at so far. I want to give a caveat before we jump into creating data frames that the API, or the Application Programming Interface, for the data frame class is enormous. There is no way we're going to be able to touch on even a small fraction of everything that it can do. So I really want to point you towards the documentation as well as just the real world practice of looking up questions that you come across as you're starting to play around with these data frames. Okay, so for creating a data frame, in general, the syntax of creating it is typically like this. I say typically because this assumes that your data is already loaded in some form. So if you would like to create a data frame as you load in your data, we can actually do it directly in the process of loading in a CSV file right into a data frame. Otherwise, if you've already got your data or it's a small enough data set that you can just create a quick list or a dictionary or series, these are going to be the three other options that have this syntax related to them. They're going to be used less frequently in this class, mainly because most of our data sets are going to be pretty large and we will be reading them in from files. And I will point out that today we're going to do it with a nice clean CSV file, but Pandas does have the machinery to be able to handle all kinds of different file types, and you don't have to have clean data to start. In the real world, you usually won't, unfortunately. Okay, so let's talk about the syntax for reading in from a CSV file, and then we'll go over to the Jupyter Notebook to do this. In general, there is this amazing function that Pandas has put together called the read CSV function. And I'm just going to jump over to the documentation for this function just to highlight basically what a crowning achievement this function is. I think of one of the main contributions Pandas has made to data science, and especially data wrangling and data cleaning, is this read CSV function. And there's a reason it has so many arguments in it. It might be one of the functions in Pandas with the most arguments, but that's because there's really a lot of difficult things to consider when you're parsing data or a file. And really, this function can handle most of the scenarios you're going to come across. So when we get into our exploratory data analysis portion of the course, we'll dive deeper into how we can use this function to read in other file types. But today we're just going to start with CSV. So let's jump over to the notebook. And this is the Pandas Part 1 data structure notebook that's in the Pandas Bootcamp folder. And we're going to be jumping down to the part that relates to data frames. Before I have closed it. Before we totally close this sidebar, I want to point out that the data we're going to be looking at is actually stored in the data folder. And in Jupyter Hub, you can click on the data files and glance through them. So I can see here that the data I'm about to load in is actually very well structured, very well formatted, and it is comma separated. So that's why it was already basically read in here in a table form. So I'm going to have very little difficulty reading this in with the read CSV function. I don't have to add any other special arguments other than just the path where this is located. So let's just zoom in for here, and we're just looking at how to create a data frame from this file. All right, so I've just read it in, and all of my data is nicely in this elections data frame. The row labels here, also known as the row index, are automatically generated by Python. if you don't specify otherwise. And so it's going to automatically start at 0 and be integers going forward from that. Now, let's say I wanted a different index, and we're going to talk a lot more about how this index is really helpful in doing fast lookups, fast queries with our data. And so maybe there's a reason that I wanted to do some analysis or quick lookups or grouping of this data by party. Then I could read the data in with party as the index, and that's one of the parameters that I can specify in the read CSV function. When I do that, now you can see party is automatically read in as the index. Again, we'll see some more usefulness of this as we go into how to group and query in future lessons, but for now, just realize this is an option. And what makes this nice is A, I can specify it, but B, my index or my row labels do not have to be numeric. They don't have to be integers. They can be strings, and they don't have to be unique. And so again, because we're thinking of these rows as representing instances of some data we're collecting, in this case, instances about elections in a given year for a given party, then it makes sense that we'd have index values that may not be unique, because the rest of the row values here are capturing more unique information that corresponds to this specific entry. All right, so that's going to be basically the bread and butter of how we create data frames. But I am going to walk through a couple of the other ways that are useful when we just have small amounts of data we quickly need to organize in a data frame. So we can create a single column data frame using a list, just like this. And so again, this column value is what I'm inputting, and that's what's getting put here. And Pandas is just doing the default row index values for this. If I want a multi-column, then I'm just going to do a nested list here as the input for the data part of the data frame, and then I can specify the names of the columns. Similar to using a list, I can use a dictionary. So again, just depends on how my data is organized. If I have a dictionary of columns, so I have the fruit column, and these are the entries in that column, and the price column, and those are the entries in that one, I can also convert that quickly to a data frame. Here I have a dictionary of columns that's going to output as this. And if I have a dictionary of rows, I will set it like this, and there it's going to output each row. So in this case, I'm saying fruit goes to strawberry, price goes to this. I have to have the same keys in each of these dictionaries in order for those to line up and get me the data frame I'm looking for. And then last, I can also create data frames from a series. So here I have two different Pandas series, and I'm going to run this here and then pass those in as objects for my columns. So now I'm using the dictionary format we had above, but I've already defined the values here. And so that's a nice way to do it, and that gives me control over what I want the index to be. Last, I can take a series as it is, so here, and pass it into the data frame, and it's going to output a one-column data frame. Or I could take a series and just call the toFrame method on it, and also I would get a data frame. So I have lots of options, and a lot of, depending on what I'm trying to do, some of these may be quicker or just more useful than others. So now let's pop back over to the slides. You can actually stay in this notebook and continue to play around with these functions as I walk through the next part in the slides. As we saw in the Jupyter Notebook, the row index, also known as the row labels, can be non-numeric. So we saw that example here. And it also does not need to be unique. So let's come back here. So in the left example, that was how it was loaded in as default. That one was unique and numeric. So that was basically corresponding to a row number. On the right, the index values are named and non-unique. And again, depending on what I want to do with this data, having my index be set to year may make my computations and queries much faster. Now you can select a new column and set it as the index as you need. So maybe you don't know when you load it in, if there's going to be some special things that will be faster if it's indexed differently. No problem. You can always just set the index when needed. And then you can always set it back. So you can do elections.resetIndex, and it gets you right back to the default here where it's just basically row numbers starting at 0. Now, I'm going to contrast the fact that, we're not restricting our row labels to be unique, but our column labels are almost always unique, really because of how we're using this data. We are interpreting columns as these unique features, and so it doesn't make sense to have repeat columns in the context of how we're using this. If you accidentally load in a column that is already named in your data frame, Pandas has your back. It'll just rename that column with the name you've given it and like an underscore, a new number, so that you'll know, oh, I have more than one columns called candidate. I better clean that up. So if you want to see basically the row labels or the column labels, there are quick attributes built into data frames that you can call just to see them. So if you would like the actual row labels, that's built into the attribute called index. If you would like the column labels, will come out from the attribute .columns. And I will just gloss over this fact that both of these are index data types. So that's really that third data type we've talked about in Pandas. We're really not going to do much with the data type itself, the index data type itself, but just to let you know, I like to just really realize that there's labels here for both my rows and my columns, and I can quickly access them and or change them as needed. So that was a quick overview of how to create data frames and how to start to manipulate the row index.